Hello, my fellow programmers. Welcome back to our C programming course. In today's lesson, we are diving into the fascinating world of pointers and memory management. Pointers are like magic arrows that allows us to manipulate memory directly, and understanding how to use them is crucial for writing efficient and powerful programs. So let's jump right into our topic. So these are the topics for today's class: memory pointers and memory management, understanding pointers and memory addresses, pointers, arithmetic, dynamic memory allocation, malloc, calloc, realloc, preloc. These all are dynamic memory allocation things. And lastly, we will see working with arrays and pointers. So maybe this video will split in two parts because we don't read any of our lecture more than 30 minutes. For easy understanding, for better understanding, we put our videos less than 30 minutes. So let's get started without wasting any time. So we are going to open a new program. Here we write hash and include, hash include stdio.h. Alright, so the man with 0. Yeah. So this is our here we are going to write our program. But before writing our program, the first thing that we have to understand about memory is that memory is very crucial in programming. When we are working with anything that acquires memory. So in our field, we have to understand that we have to use memory very efficiently. So we try to use that functions that deals with memory. Pointers are the variables that has the power to hold addresses. So let's understand it deeply. Let's think of a pointer as a variable. Pointers, because as I told, pointer is like a variable. It's just like a variable that stores the memory addresses of another variable. Actually, and this thing opens a whole new world of possibilities. In programming, it's like having a GPS. It's like having a GPS for memory locations. You can access and modify any variable directly by navigating through these addresses. So this is the use of pointer. You can access any variable directly and modify it by using its address. Because pointer is a variable. Pointer is just simply like a variable that holds the address of another variable. So let's see this thing practically. We already written a code, so we don't have to worry about it. Yeah, we are going to copy it, and we are going to paste it here. Yes, so this is our code. So let's understand. Let's see what is pointer basically. Okay. So int num is equal to 42. Num is a integer type variable, as we all know that. Then after that, we initialize a int type pointer. Pointer is a variable, as we discussed, that holds the address. So here we declare the variable, and here we assign this variable, pointer variable, address of num. We are assigning the memory address of num to PTR. And when we are assigning any addresses, we use this sign of n percent. This is a sign of n percent. We use this for assigning of addresses. When we are mostly dealing with addresses, we use this n percent sign. And here is a initialization of pointer, and here we assign the address of this variable to PTR variable, which is a pointer type variable. And this variable is num is int type, so we made our pointer also of int type. So let's explore the values. So we have to print the value of num. We simply do that by writing here num. For the address of num, we write here num. and percent num, which shows the address of num. And for value of PTR, as we know that PTR and num words are the same value. It's just that the difference is just that PTR has the address. You can deal with address through PTR because PTR is a pointer. So let's see it by pressing F11. You have to save it, for example. So here we have the answer. Here we have the answer. Value of num is 42, as we all know that. Here we initialize point num is equal to 42. Address of num. The address of num is this. On the memory side, this is the address. So this is some unique variable or a unique thing. So it is the address of that variable. And here value of PTR. So basically what PTR shows here, as we discussed earlier, PTR basically holds an address of a variable. So we can see that the address of num and the value of PTR is same, which means that the address of num is equal to the value of PTR, because PTR is a pointer type, and we discussed that pointer type variables hold the address of any other variable. So it holds the address of num variable. So this is how we can access, this is how we can assign any variable address to pointer. So now let's move on to our next topic for today's class. Pointers arithmetic. Yeah, it is very important topic. Pointers arithmetic is very important topic. So pointers arithmetic is another powerful concept. As I said, it's like steps to memory address. I can explain it like when you increment or decrement a pointer, it actually moves to the next or previous memory locations. So when we, as we see here, this is the address of num. For example, suppose that this is the address of any other variable. We can take an example also of our pointers arithmetic separately. You can take an example, but we can understand from this example that if we increment in the address of PTR, it will move to any other variable, because any variable that is saved after this variable num, then the pointer moves to that variable if we increment or decrement in our address. So when we increment and decrement our address, it means that we move our pointer to another variables, to other variables, and it basically based on our data types, because memory locations such are different according to data type size. So let's see its separate example of pointers arithmetic. So here we have, yeah. So we can say, so see what happened in this program. This is an array as we studied, and this is simply elements of array. And here is a PTR pointer, and we assign, this is also a way of assigning to any address to pointer variable. So basically we assign array to our pointer. So as we discussed, by increment and decrement in values, what happened? We pointer move to another value. By increment and decrement in the value of pointer, so it basically what happens in the memory side, if we increment the address of memory, it will shift to it will become any other address. So it will move on that variable. So it will, and if we decrement the variable, same thing happen. It will move to another variable in that way. So let's see here. So here we basically just declaring assigning the value of array to PTR pointer. And here what we are doing, as we can see that PTR, printf, first element %d, and here we write static PTR. When we use static PTR and %d here, the data type format we use here, then it will show the value that it holds. Initially, it pointer holds the 0 index value, which is 10. And to move it, we increment the address of pointer PTR. We increment in the address of pointer, not in static value. Not in static value. We increment in the PTR. PTR that is an address. So we move to increment it, so it will move to the next element. And we know that what is the next element? Second element is 20. So printf second element. Second element had here we write this again static PTR, but now PTR is increment by 1. So it means that it will move. So it will move to second element. So it shows the second element because we increases the pointer by 1. So let's see this program. What is the result of this program? Yes, as I said, our first element 10, second element 20. First element PTR, static PTR shows that because initially it stands on 0 index. 10 is on 0 index. And on second, and when we increment, you can see that statement, when we increment the pointer, which means that we can increment it in the address of pointer, it will shift to the index 1. And index 1 has a value of 20. So when we print the pointer's value that it holds, the address it has, and that on that address what value is stored, then if we want to see that value, we use this static sign at PTR. And when we see the value is 20 because it will pointer move to another value from 0 index to 1 index. So this is how you can this is the arithmetic of pointers. You can increment and decrement pointer, and you can move to any other variable or any other element. So this is about this. Now let me see what we have to see. Yeah, dynamic memory allocation. And working with arrays and pointer, we will see this topic in our next part. So stay with us and try to watch these two parts simultaneously so you can do practice in a more better way.